Now, first we'll directly head on. What is oscillation? What do we mean by oscillation? Can someone say what is oscillation? Oscillation kya hai?
To and fro motion.
To and fro motion. Nice. Okay. Oscillation, we call it as to and fro motion. Okay. Nice. Nice. Okay. So does someone know the example of, can give an example for oscillatory motion? Simple pendulum. Simple pendulum. Is it oscillatory in nature?
Yes, sir.
Yes. Okay. Okay. So I think we will move on with this. Before that, I will just share this video. Just look at this and then we will discuss. Okay. So you see, there's this nice video on several examples of oscillations. Okay. So I just pause this video for a moment. Can you see here? There are two bodies which are oscillating. One is this iron ball which is making to and fro motion. Okay. And then you have this circular ring which is rotating. So both of them has their own angular frequency of rotation or time period of rotation. You see that the two times are nicely matched. So the two objects move in such a way that one does not collide with the other. Okay, can you see here? So there is very nice matching of the timings. Okay, can you see? Just 1 minute. I think someone wants to get in. Maybe principal, sir. Okay. Yes. So here also, can you see there is a circular ball which is moving along this circular track. Then you have this circular ring which is suspended to a spring and it is making to and fro motion. So both these objects are moving in such a way that one does not collide with the other. So therefore, again, there is an instance where the two timings are matched. Okay. So here you can see, right, one set of cylinders are moving towards left side. The other set of them are moving or approaching the screen. Okay, and both these set of cylinders are moving in such a way that they are not colliding or not interrupting the movement of the other. Okay, which means to say that the timing of both the movements, both different set of cylinders, has been matched. Okay. Okay, so is this video interesting for you? Was it nice?
Yes, sir.
Okay.
Yes, sir.
Okay, Pa. I think with that we will now move on to the topics. Okay. And can you just see here? So today, what are the things we are going to cover? So today we will review. Okay. Today we will revise or recollect the properties of simple harmonic motion. So along the way, yeah. So today we will recollect. So today we will be revising. Hi. So is it now visible? Wait, I'll just zoom now. Is my screen visible now? Yeah. This should be fine. Okay. So today we will revise about simple harmonic motion. So along the way, we will be we will be defining the following terms, which we call it as technical terms. They are something related to displacement of an object that is performing a simple harmonic motion. Then what is amplitude of oscillation? Then we'll look at the frequency of oscillation. Then we'll look at angular frequency. We will define what is time period. Then we'll define what is equilibrium position. Then we'll see what is the relationship that connects the frequency of oscillation and the time period of oscillation. Then we'll also discuss what is restoring force. Then we will define what is simple harmonic motion means, and we will do this. We'll define all these 9 definitions by considering the following 2 examples. One in which a body is attached to a spring, and the second one is a simple pendulum. Okay, so we will be discussing what by considering a body which is attached to a spring, we will, or a simple pendulum. In either of these case, we will see the properties of simple harmonic motion. And properties of simple harmonic motion means what? We will refer to how the position of the object varies with the time, and also how the velocity of the object will vary with the time. Okay, and there are three cases of simple harmonic motion are there. They are, one we call it as free oscillation, other is going to be damped oscillation, and the third case is going to be forced oscillation. In each of these, we will discuss the equation of motion and the properties of the oscillation in those 3 setups. Okay, and then in the next class we will discuss or will derive the differential equation of motion for simple harmonic motion and then free oscillations. Okay, first, now let us consider one term at a time. Okay, what is displacement? Then all of you look at this figure here. Just look what I'm showing here. Can you see here? For example, I'll consider a simple pendulum. What is a simple pendulum? A simple pendulum is an arrangement in which a mass is attached to a string. Okay, for example, look here. So this is going to be my wall. This is the wall. Okay, and this is my string of length L, and to this a bob of mass M is attached. Okay, a bob of mass M is attached. Okay, is this clear? What is a simple pendulum? A simple pendulum is an arrangement in which a bob of mass m is attached to this string. So what are the terms we were supposed to discuss? I myself forgotten. So the terms we were supposed to discuss were displacement, amplitude, frequency, angle of frequency, period, and so on. Okay. So I think we'll just we'll start with the displacement. Okay. So where was I? Yeah. So we started with a simple pendulum. Okay. Yeah. I considered a simple pendulum. Correct. So this is what is a simple pendulum. A simple pendulum is an arrangement in which a bob of mass m is attached to a string. Okay. So this is string. This whole thing is what? It's a string. Okay. Now look here. What I will do is, correct. Yeah. So now what I'll do is I will displace this object in this direction. Okay, I'll take it, I will hold this object in my hand and I will move it towards the right and leave it. Okay, what does that mean? What does that mean is this object, so I have taken and it is somewhere here at this point. Okay, somewhere here at this point, the same object I have taken and have left it. Okay, this angle may be theta naught or 45 degrees or 50 degrees. Okay, I'll just call this as theta naught. Theta naught refers to what I call it as amplitude. We'll discuss later. Okay, now look here. I took this object, I moved it towards left side and I have left. Okay, I have left. I've taken my hand out of it. Correct. Now what will happen to this object? Will it move or it will remain in the same place? What will happen to this object? What will happen? Will it move or it will be in the same place? Will it move towards right?
Position.
It moves towards right, correct? Yes or no?
Yes, sir.
It moves towards right, correct? Right? Am I right? It moves towards right. Am I right? What direction it will move? It will move towards right. Am I right? Okay. Now look here, as time lapses, what will happen to the speed of this pendulum as it approaches the, suppose I take a pencil, red color. So as it approaches the mean position, okay. As it approaches the mean position, what will happen to its velocity? Will it increase or decrease?
Decrease, sir.
Velocity, what will happen? Will it increase or decrease? See, if an object is falling down, what will happen to its velocity as time lapses? Increases or decreases?
Increase, sir.
Increases. Correct? No? Right? So what happens here? When this object, look here, I'll use for example, so for example, when this object, okay, when this object is approaching the mean position, what will happen? Its velocity will increase, and at this spot, what happens? At this point, this I call it as reference position. At this reference position, what will happen to its velocity? Its velocity is going to be maximum. Okay, now let us look at this following 100 meters running race by Usain Bolt. Okay, so for example, okay, I'll just define this concept and then we'll continue in the next class. Okay, now observe this video of a 100 meters running race in which Usain Bolt has achieved an world record.
I've seen that. Chambers in 1, Burns in 2, Bailey in 3, Bolt, Olympic champion, world record in 4, Gay, the defending champion in 5, Powell, the fast man who usually fails to deliver in 6, Patton in 7, Thompson in lane 8. Away first time, good start from Bolt. Bolt leaving a moment and going away. Gay trying to go with him, and he's being dragged through to second place, but he's going to win it by 2 meters. 9.58. The world record's gone. That's more like it. Sub 9.6. Everybody expected Bolt to win. Everybody expected Gay to be second. That's what we've just seen. But for Gay to produce that performance, you're dead right. He deserves enormous plaudits. Here's that race again. Bolt was away and gone by 60 meters. Massive stride, big man. Gay battling all the way.
I think now you can see in this video, right? So all the athletes are in their respective track. So when the race starts, each of them will accelerate. Their speed will increase with the time, correct? When they approach this finishing line, what happens to their speed? Speed is going to be maximum, correct? And what do you see? The athletes, even after crossing the finishing line, they continue to run for some more distance, correct? Am I right?
Yes, sir.
Yes, sir.
You see here, even after crossing the finishing line, the athletes run for some more distance. Am I right?
Yes, sir.
Right?
Yes, sir.
I think the idea is clear, correct? So likewise, so look here, I'll use the brush. I'll use this. Can you see here? So I'll use blue color. Okay, can you see here in this figure, as the objects are as the pendulum is approaching the mean position, what is happening to its velocity? Velocity is maximum. And here what happens? At this point, velocity is maximum. Can it stop? No. Am I right?
No, sir.
Why? We call it as inertia. Therefore, what will happen when the bob approaches this mean position? It continues to move upwards. Correct? Am I right? Yes or no? So,
Yes, sir.
therefore,
Yes, sir.
what is inertia? I'll put in simple words. If inertia is the tendency of the body to remain in the same state of motion. Okay. So this pendulum. So this pendulum was in motion. When it approached this point, it cannot come to rest, and its velocity is maximum, speed is maximum. Therefore, it continued to move up. This much is clear. Therefore, what happens? Look here. So when the object, I will use now a different color. For example, where is my cursor? Yeah. I'll use say green color. Yeah. When this object approaches the mean position, velocity increases with the time, and it reaches maximum at this point, which I call it as mean position or equilibrium position. When it moves away from equilibrium position, what will happen to its velocity? It will decrease. Correct? No. Therefore, what happens? What happens is, can you see here? I'll draw the same diagram here. So this is the body. So this has been displaced at this point, and I have withdrawn the force. Therefore, what will happen? The body will approach the equilibrium position. It will move away from equilibrium position. It again comes back and it goes. It makes to and fro motion, as I have said. Okay. And what happens at this point? At this point, we call in calculus as turning point. Okay. So this is the point where the velocity of the object is going to be 0. Okay. Velocity V is equal to 0. Okay. I did not write V properly, but I am telling orally. Okay. It's not Y, it is V. Okay. Velocity of the object at this point is going to be what? 0. Velocity of the object at this point is called, it will be 0. What is this point called? This point I'll call it as amplitude. So this is the amplitude. Okay. For example, this could be theta naught, could be 45 degrees. Therefore, how does velocity vary with the time when an object performs simple when it executes to and fro motion? So the velocity will, so when it approaches the mean position, velocity will increase. At this point, velocity is maximum. It cannot come to rest. It will continue. Therefore, when it moves upwards, its velocity will decrease. Here it will again come to 0. Therefore, in the process, what will happen? The particle is going to execute to and fro motion. Okay. This I call it as what? This angle I call it as displacement. Here it is angular displacement. Is this clear to you all? What do you mean by angular displacement? Angular displacement refers to, what do I mean by angular displacement? So somewhere the particle has been displaced away from its equilibrium position. Somewhere a body has been displaced from its equilibrium position. So this displacement, I call it as what? This point I call it as angular displacement. This is clear? And what is amplitude called as? Amplitude we call it as maximum displacement from the equilibrium position. Okay. So what is amplitude called? Amplitude is referred to as maximum displacement of the object from its mean position. This much is clear. I think I will stop here. Tomorrow, I think we have a physics class in the morning. I'll continue during that time. Okay. So therefore, now I'll stop here. I'll take your attendance and wind up. Okay. So from next class, it's going to be roughly 12 to 12:55 or 12.